In this video, we are going to be working on reviewing graphing parabolas, quadratics in standard form. Please remember that standard form is y equals ax squared plus bx plus c. So in our first problem, remember we're going to take a look at the leading coefficient, which is the number in front of the x squared. If it is positive, it's going to open up. If it's negative, it's going to open down. Secondly, we want to find our axis of symmetry. And remember, our axis of symmetry is x equals negative b over 2a as the formula. So the number in front of the x squared is our a, the number in front of our x is our b, and the c is by itself. So the opposite of b in this problem will be negative 2, and then we'll take 2 times the leading coefficient a is 1. So we have negative 2 over 2, which will be negative 1. So our axis of symmetry is x equals negative 1, remembering that it is a vertical line that passes through negative 1 on the x-axis as our axis of symmetry. Then to find the vertex, we are going to take the x value of negative 1 and we're going to plug it in, substitute it into the equation to find our y value. So negative 1 squared is 1, 2 times negative 1 is negative 2, and then we subtract 5. So 1 minus 2 is negative 1, negative 1 minus 5 is negative 6. So our vertex, since it goes on the axis of symmetry, has the same x value as our axis of symmetry, and the y value after we've substituted it in is negative 6. So we're at negative 1, negative 6. Okay. Then remember that our y-intercept is our c value as long as our equation is in standard form. So our y-intercept is going to be at negative 5. We'll create our table by using our parent function values. Our x values will be 0, 1, 2, 3. Then we're going to square each of those. And then we ask ourselves, if the leading coefficient is other than 1, we're going to make our third column. But this case it is 1, so we don't need our third column. So I'm going to circle the 0, 0 to remind us that that is our leading coefficient. Excuse me, that's our vertex. And now we will go over 1 and up 1, and over 2 and up 4, and over 3 and up 9 as we plot the points that are in our table. And then we're going to reflect those points to the other side of our axis of symmetry because our quadratic, our parabola, is symmetrical. And then we will draw in our parabola. Next problem we're going to do, our leading coefficient is negative 2. So we know that our parabola is going to open down. Our formula for our axis of symmetry is x equals negative b over 2a. So we're going to substitute those values, remembering a is our leading coefficient, b is the number in front of the x, c is our constant value. Negative b, the opposite of b would be negative 8. And then 2 times a, which is negative 2. So we have negative 8 over negative 4, which is 2. So our axis of symmetry is x equals 2. Our y-intercept is our c value as long as our equation is written in standard form. our vertex has an x value of 2, then we're going to substitute that x value into our equation, and we're going to solve for y, which gives us the y value of the vertex. 2 squared is 4, and 4 times negative 2 is negative 8. 8 times 2 is 16, and then we have minus 5. So negative 8 plus 16 is 8, and 8 minus 5 is 3. So our vertex is going to be at 2, 3. I'm going to draw in my axis of symmetry at x equals 2, which is our vertical line that passes through the value of 2 on the x-axis. Our vertex is at 2, 3. We're going to do our parent function table. Then the second column will be the values squared. And this time, since the leading coefficient is negative 2, we're going to multiply the middle column by negative 2, which will flip our parabola, and it will also stretch it. It will make it taller and more narrow. So we cross off the middle column, circle the 0, 0 to remind us that that is our vertex. From our vertex, we're going to go right 1 and down 2. And then we're going back to our vertex, and we go right 2 and down 8. Then we're going to reflect those points to the other side, draw our parabola. Our third point doesn't fit on our graph, so we'll just leave that. And this was our review of graphing parabolas in standard form.